In this video, we're going to have a look at three special angles. Right-angled triangles that have a 30, 45, or 60-degree angle have ratios that can easily be determined without using a calculator. And that is why you are expected to know these triangles and be able to determine the ratios without a calculator. If we focus on the 45-degree triangle, you will see that this is an isosceles triangle because both the other two angles are 45 degrees. This means that the adjacent and opposite sides will always be the same length, and in this case we chose to make that 1 unit each. Using the theorem of Pythagoras, we can then determine the hypotenuse, and that will be the square root of 2. If we have a look at the 60-degree triangle, you will see that if the one angle is 60 degrees, the other one will have to be 30 degrees because they are complementary angles. In this triangle, the adjacent side of the 60-degree angle is 1. The adjacent side of the 30-degree angle is square root 3. And using Pythagoras again, the hypotenuse is 2. For the next few examples, you need to know these two triangles along with the three trig ratios by heart. Example: determine each of the following ratios without the use of a calculator. Number 1, cos of 60 degrees. Here we need to start by naming the sides from the 60-degree angle's perspective. So the square root 3 is our opposite side, 1 is our adjacent side, and 2 the hypotenuse. The cos ratio is the adjacent over hypotenuse, and that will be 1 over 2. In number 2, we need to determine the sin ratio of a 45-degree angle. So for that, we're going to start off naming the sides of the 45-degree triangle. The sin ratio is then the opposite over hypotenuse ratio, and this will be 1 over the square root of 2. For question 3, we now need to look from the 30 degrees perspective, which means the opposite and adjacent sides will now be swapped around. The tan ratio will always be your opposite over adjacent sides, and for the 30 degree, that will be 1 over the square root of 3. In question 4, we now need to divide two ratios, both looking from the 30-degree angle's perspective. Sin will then be the opposite of 1 over the hypotenuse of 2, and this should be divided by tan also from the 30-degree perspective, and that will be the opposite, which is 1 over the adjacent of square root 3. I wrote the division next to it just to write it in a clearer way. Now I can change that division into multiplication if I multiply with the reciprocal of the fraction that comes afterwards. Now I can multiply my numerators. 1 times square root 3 is square root 3, and I can multiply my denominators, and 2 times 1 is 2. In question 5, we are once again looking from the 45-degree angle, and now we need to square this ratio. So I'm going to start off writing the cos 45 ratio in a bracket so that I remember to square that. Cos is the adjacent side over the hypotenuse, and in this case that is 1 over square root 2. If I now go and square the numerator as well as the denominator, my final answer is a half.